Okay, guys. One last, look kind of with dealing with all of our simplifying, multiplying, dividing, adding, subtracting radicals. Lesson 6.4, even though it doesn't say radicals, we're still dealing with radicals. Lesson 6.4 is rational exponents. Okay, so we're going to be spending our time looking at how do radicals connect with exponents. And this is a big thing to be able to go back and forth between the two. So, as you look right here, and it's 50-50 whether Mrs. Rogers introduced this in Algebra 1. I know it can come up in Algebra 1, but I'm not 100% sure it's in the standards. So I'm not 100% sure if she introduced it or not. But the idea that something like the nth root of x, whether it's the square root, the cube root, whatever, the nth root of x is equivalent to x to the 1 over n power. So we can take something that's in a radical and change it and write it with a fraction exponent. Okay? The example over here is something like x to the m over n. Well, that is equivalent to saying the nth root of x to the m, or the nth root of x raised to the n. The idea, notice in both cases, the n that's in the denominator correlates to where? It is in the index place, that root, or the little number someone said yesterday, okay? It is that little number, and it is that index is the official vocabulary. And then if you have a number in the numerator, it's the power, whether you put it under the radical or outside of the radical. So the idea that, let me give you an example. If I say the cube root of x to the 6th, we can take that out of radical form and write it as an x with a fractional exponent. So in other words, this can be written as x to the, 3 is my index or my root. So where did I say that always goes? It always goes in the denominator. So 3 would be on bottom. 6 is my power. Where does it show the power going? M goes in the numerator. So this could be written as x to the 6 over 3. And we know 6 divided by 3 is 2. So it's also equivalent to x squared. So that is a big part of what we're looking at today, being able to go back and forth. Okay? Our other simplifying rules are still going to be used on and off some, but it's just being able to go back and forth here. Questions on what I did there? Okay. Let's look at example A. And they're asking us to simplify these things, and these things have the rational exponents. They have exponents that are fractions. So if I ask you 216 to the 1/3 power, do you know what that is? How do you figure 6?
Because if it's to the 1/3 power, it's like having 216, like 216.
Okay. And so, in this stage in the game, what I'm going to suggest is let's convert it. 216 to the 1/3 is equivalent to putting 216 under the radical. Okay? Know this, memorize this. 3 is in the denominator. So where does that mean that 3 goes in the radical? It goes as the root or the index. 1 is in the numerator. So officially, where does the 1 go? On the power. Which, do I really even have to write that 1 in? No. So, now can we simplify this? Do we know the cube root of 216? Yeah, it's on your blue paper, right? Cube root of 216, count down, is 6. So what that also means is the 216 to the 1/3 power is 6. So 1/3 power just means take the cube root. Questions on how I work that? I'm just trying to figure out if you guys are convinced or not. So, okay, let's try B. 7 to the 1/2 times 7 to the 1/2. What can you figure out about 7 to the 1/2? It's the square root of 7 because the denominator of 2 is my index, the numerator of 1 is my power. So it's the second root of 7 to the first. But what do I mean when I say second root of 7 to the first? That's a fancy way to say square root. And then the other 7 to the 1/2 is going to be the same, right? What is square root of 7 times square root of 7? Square root of 49, which is 7. And if you're there, can you just say square root of 7 times square root of 7 is 7? Can you do that? You can. And square root times itself is just a square root. Okay. Let's try C. 5 to the 1/4 times 125 to the 1/4.
Could you pick them both under the radical and then multiply them?
Yeah. Okay. I would encourage us right now, let's put them up, think of them individually, right? But then, yeah, we're going to be able to end up multiplying them into one radical and simplify from there. So if I have 5 to the 1/4, what kind of root is that? Denominator is 4, so it's the 4th root of 5. 125 to the 1/4. Denominator is 4, so it's the 4th root of 125. What do you guys remember about multiplying with radicals? You can multiply with radicals as long as the index is the same. So what is the 4th root of 5 times the 4th root of 125? 4th root of 625. Do we know the 4th root of 625? On my paper, it's listed, right? So count down. 2, 3, 4, 5. It is equivalent to 5. As you get better at these, you might not actually have to convert over. As in, I say 64 to the 1/2. Are you there? Can you just tell me what that is? Or do you need to process through it? I agree. And if you're processing through it, 64 to the 1/2, what's that 2 tell me? 2 is in the denominator, so this is the square root of 64. And the square root of 64 is 8. Again, some of you can process through this quicker than others. Think with me, though. 11 to the 1/2 times 11 to the 1/2. Yeah. 11 to the 1/2. That 2 goes in the index, so it's the square root of 11 times square root of 11. What is square root of 11 times square root of 11? Okay. I heard two different things. They're both good. I heard square root of 121. I heard 11. I don't care which way you go. Technically, if we wanted to go another way on this particular problem, if you wanted to use your exponent rules here, you could. I don't know if anyone's trying to use exponent rules, but what happens when you multiply and the bases are the same? If you're multiplying the bases are the same, you keep the base the same and do what with the exponents? add them. What's 1/2 plus 1/2? 1. So then it's 11 to the first, which, isn't that what I got here? Okay. Not the route I'm going to go as much. I think we work better if we change them to radicals. But, okay. 3 to the 1/2 times 12 to the 1/2. Now, see, this is one where my exponent rules don't work here because my bases aren't the same. So I can't just multiply those and go from there. So, what do you know about 3 to the 1/2? What is that saying? That is the what? Square root of 3. What about 12 to the 1/2? Square root of 12. What's the square root of 3 times the square root of 12? Square root of 36. And what do we know about the square root of 36? 6. Are we okay with that? Not too bad? The key will be being able to remember it tomorrow. Okay, so we've worked with the numbers a little bit. Let's go work with some variables here. And so example 2 is just being able to convert these over. They're giving me problems that are in exponential form, a variable with an exponent. How do we write these as a radical? So if I have x to the 3/7, think like we just were. What do I mean x to the 3/7? How do I write that with a radical? What'd you say?
Is it 3 to the 7th?
Not exactly. 7th root of x to the 3rd. So, okay, so we're getting, where does that 7 go? That 7 is still the index, right? So denominator goes there. The x is my base. And what is the numerator? It's my power. And I think I heard the 7th root of x to the 3rd, right? I think I heard that for a couple different people. To me, this is how my brain sees it. This is how my brain writes it. However, you also could write it as the 7th root of x raised to the 3rd. Okay? Something like that would not be counterable. Honestly, I don't think you guys would do that. That's, you know, a little bit extra work, really, in a way it seems like. So, both are equivalent, though. Even though we wouldn't necessarily write it like such, like that second one as much, it's helpful to sometimes be able to think about. Because when we get to talking about simplifying these, which I think is more on the back, when we start thinking about simplifying these more, sometimes it's easier to take the root first and then do the power. Whereas sometimes it's easier to do the power and then take the root. Are we okay with that one? So quiet today. Okay, B. Y to the negative 3.5. And I want it in radical form. If we're going to go radical form here, right now I have a decimal. Do we know anything about how to convert a decimal to a radical form? A decimal exponent? No, we've been converting fraction exponents to radical form. So can you make negative 3.5 a fraction? Yeah, what is negative 3.5?
7 over 2.
Okay, and if you need to first think, it's negative 3.5, if you want to go the long route here. You need to see that. It's negative 3.5, but negative 3.5 improperly becomes negative 7/2. Now, a couple of things. Before I worry about that exponent, I don't have a rule of how a negative exponent applies to my radical. But what do I know about negative exponents? How do I get rid of a negative exponent? Did I hear it? Take it to the bottom, right? Go over that magic line, go over that fraction bar. So in order to get rid of my negative exponent there, if I have y to negative 7/2, to make that positive, I'm going to say 1 over y to the positive 7/2 now. Can you write that y as in a radical now? I'm still going to say 1 over. 1 over what? Okay. The square root of y to the 7th. And it's a square root because the 2's in the denominator. 7th power. So, do you have to write that 2 there? No. Does Math Excel count you guys wrong if you put that 2 in there? Has anyone tried putting the 2 in there and gotten count off? Or do you just not try it? Okay. Because I honestly don't know. I mean, if I'm grading a paper or pencil assignment, I'm not going to count off if you write the 2 in there for a square root. It's, not wrong in my mind. But so one way to write this answer is 1 over the square root of y to the 7th. Now, notice I said one way to write that. Square root of y to the 7th. Is that simplified?
No, because it's split into 4 and 3, right?
Okay, so there's a couple different things we can think about. First of all, are there any perfect squares in y to the 7th? I don't want that. Yeah, okay, so let's review. Exponents. How do I do the square root of an exponent? Do I actually take the square root of the number? You have to be able to what? Divide by 2. So does 7 divide by 2? No. Closest number to below 7 that divides by 2. 6. Okay, so an option here is to break this up into 1 over the square root and break it into y to the 6th, y to the 1st. Remember how we've been breaking them up so we break up our perfect squares. If we do that then, what is the square root of y to the 6th? Square root of y to the 6th, you can take 6, divide it by 2, and it's what? Y to the 3rd. And then the other y stays under the square root. This is another answer. I have boxed on my paper. Now, I'm going to stop there because I've stopped there on my notes, which, unless I've goofed up, that means they don't make you go one more step. Because what would be the one more step that we could talk about here?
Getting a radical out.
Yeah, technically you're not allowed to leave a radical in the denominator, right? How would we get that radical out of the denominator? You'd have to rationalize, you'd have to multiply by, not conjugate in this case, because it's not anything added and subtracted, you just multiply by square root of y. Okay? I'm noticing I don't have it on my notes here, which means they're letting us leave radicals in the denominator here. Okay? But if we needed to rationalize, we would. Now, before we start on C, I don't know if you guys can tell or not, that is w to the negative 5/8. The negative and the fraction bar kind of went together, but can you tell it's an extra long fraction bar at least? Maybe. I don't know. It is a negative 5/8. Go with it. Okay. What are you thinking here?
One over the fifth root of y of w.
Okay, so to get rid of that negative exponent, we have to take it to the denominator. So if I write it without the negative exponent, it's 1 over the exact same thing. So 1 over w to the 5/8. Now to get it out of a radical, or to get it into a radical, it's 1 over something. What kind of root is that? 8's in the denominator, so it's an 8th root. 5's in the numerator, so it's a 5th power. So 1 over the 8th root of w to the 5th. Am I done? Or can I go more? Are there any perfect 8th roots in there? No, because I only have 5 w's. I would have to have 8 of them to have a perfect 8th root. So in this particular case, unless you're asked to rationalize, you're done. I think that's part of the reason we're not rationalizing there, because that one would be a little trickier. Okay. D. Z to the 0.2 power. Okay, so my brain, if I read this properly, I purposely did not read the math way I should. I said 0.2. What is 0.2? And it is 2/10 is how we properly read it. So if you make that a fraction, it is z to the 2/10. Now, it would be in your best interest, before you go radical, what do you know about 2/10? It reduces to 1/5. So I could actually think of this as z to the 1/5. Is that getting easy to be able to put in a radical form? It's z to the 1/5, so that's saying the 5th root of z, that is 5's in the denominator. So automatically, the 5th root of z. If you really want to, you can say the 5th root of z to the 1st. That's equivalent. Okay, reverse it. Have you tried that bottom row yet? Have you reversed it? Given to us in radical form, we're going to reverse it and go fractional, exponent fraction form. I can't talk here. So, a is the square root of a to the 5th. Can you write that with an exponent? A to the what? So how do I know? Is it a to the 2/5 or a to the 5/2? Okay. My invisible index there is 2. Where does the index always go? In the denominator. And that's, I don't know, that's the best way I can, that's the question I'm always going to, that's how I will always try and connect it. Index, denominator. Okay? Just know that the other number goes in the numerator. And a to the 5/2 is just a to the 5/2. What about b? The 5th root of b raised to the 3rd power. B to the 3/5. Because that puts my index of 5, the 5th root, in the denominator. Fourth root of x to the 3rd. X to the what? 3/4? 4 is the index, goes in the denominator. Power goes in the numerator. The 6th root of y raised to the 4th.
If we reduce 2/3.
Okay, so for starters, y to the 4/6, but as proper form always, you should try and reduce where you can. 4/6 reduces to 2/3. Okay, I'm going with that's probably a nice break of where to stop. I will tell you, so tomorrow I will plan to finish 6-4. Now, as you look at the back side on 6-4, I will not be doing the bottom row. Okay, we will not be doing the bottom row. We will only focus on doing some of the examples, some or all the examples from the top 2 rows. Now, you are still welcome to go ahead and get started on homework. If you look at it right now, I believe it says it's due tomorrow. I will get that changed. Okay? So you can start working at 6-4. Tomorrow, with any luck, I can teach you can have some work time. Okay? In the meantime, make sure 6-3 got done, please. You've got to